Right, in this video I'm just going to show quickly how we can use Algodoo to create a kind of simulation of two-dimensional collisions. So Algodoo is a physics sandbox app. So if we just search for it in Google, you'll find Algodoo, and it's free and it's quite powerful. You can do quite a lot of stuff with it. Alright, so this is where you download it. Obviously download for Windows or Mac. I've already downloaded it, so I'm just going to run it off my computer. There it is, Algodoo. And when it opens, you get this world. Right. So in here we can simulate all kinds of physics stuff. So it defaults setting gravity to be down here. And I don't want any gravity in this because I want this to be sort of like an ice rink viewed from above. And I'm going to remove all air resistance as well. So let's get rid of that. And then I'm going to add a grid, and I'm going to remove this thing, this wall here that used to be the ground, so that I just have an empty grid. Okay, then I'm going to create a couple of disks here. One large one and one slightly smaller one. Okay, and the cool thing about this is that you can zoom right in and work finely, or zoom right out and make the whole thing bigger. Okay, I'm going to right click and just drag. That allows me to move what I'm looking at. And then I'm just going to zoom in a bit to get a finer grid, and I'm going to move this big one. So choose the move tool and move this big one down a little bit. It takes a little bit of experimentation to get the hang of how all the tools work, and then zoom back out. Okay, so now I have these two disks. If I right click on one of them, I can change all kinds of things. So I can change the material they're made of, which changes things like their restitution and their mass and density and stuff, or I can manually change these things. But I'm going to leave this pretty much as it is. And I can give these things an initial velocity before I play the simulation. So if I give this thing a velocity like that, and it's already 0 degrees is in the positive x direction, so that's the direction that I want it to go to collide with that. And I'm going to just visualize the momentum, which gives me a little arrow so I can see which direction the momentum is. And I'll do the same thing with this one. In fact, I want this one to be stationary, but I'm going to visualize this one's momentum as well for a start. Okay, and then zoom out a bit, and then I'm going to let my simulation play through once just to check that. Oops, that's a bit fast. I might just reduce this velocity. You can reduce the velocity. Another solution for this would be to reduce the simulation speed, so you can reduce the speed at which the simulation runs. But I'm going to go with reducing the actual velocity of this thing to about 2 meters per second, and see if that creates something that's more reasonable. Doing. That looks pretty good. I'm still not seeing the momentum of this thing. That's probably too small, that's why. Well, no worries. So these two things are going to collide. I'm just going to add a tracer so I can see kind of the track that they go. So we can add that. I'm sure that we can add it here. Attach a tracer, there we go. And I'll do the same to this one. Attach a tracer, there we go. So now we can see the path that they took. Alright, so that's a starting point. We can do much more with this. We can right click on this and we can choose show plot. And I'm just going to take this and drag it down a little bit so it doesn't obscure what I'm looking at. And on the x-axis we have time. On the y-axis, I don't want speed, I want x and y momentum. Okay, so now this graph here, while the simulation runs, is going to show the x and y momentum, and this graph here is going to, is going to show the x and y momentum of this object. Okay, so now if we play, we can see the x and y momentum of the two objects. So initially we have, if we look at the bottom yellow line in this chart here, we have 0 y momentum because it's traveling in the x direction. And then after the collision, we have a small y momentum of half a Newton second, or half a kilogram meter per second. The x momentum started off at what looks like about 3.15 Newton seconds, and it dropped down to what looks here like about 0.8. So that's reduced by about, what's that? 1.35. 1.35. Okay, so, and if we look at the smaller one here, we started off with 0 momentum of any kind, and then as we moved at the collision, which with this kind of restitution of these objects clearly is almost instantaneous, the y momentum went from 0 to negative 0.5 approximately, which is about as much as this one increased. So the total y momentum remained 0. Similarly, the decrease here in the x momentum, decrease of, what did we say, 1.35, corresponds to this increase of about 1.35. And so we can see that momentum is conserved in both the x and y directions. Okay, so this is a really simple collision. With this simulation you can do, well, kind of anything you can imagine, as long as it's two-dimensional. So it's a really powerful simulation, and one of the many things that you can do is look quantitatively at these two-dimensional collisions. So it's well worth having a play with this, both for this and for other things.